Chapter 3, Think and Discuss. Problem 80. Can an object reverse its direction of travel while maintaining a constant acceleration? If so, cite an example to your classmates. If not, provide an explanation. Well, yes, it can. And we've done it in class, and it's various problems that we've dealt with before, but a ball thrown into the air, acceleration is constant, which is it's a downward acceleration. It slows it down when it's going up, and it speeds it up as the ball object's going down. So it can reverse its direction of travel while maintaining constant acceleration. Remember, acceleration deals with a change in velocity. It does not deal with the velocity itself, but the change in velocity. And so as velocity goes from positive to negative, there is a change. And so, or negative to positive, whichever way it's going. So that's 80. 81. For straight line motion, explain to your classmates how a speedometer indicates whether or not acceleration is occurring. So for straight line motion, you can indicate, remember that acceleration is based upon change in velocity. So velocity changes if there's a change in speed or a change in direction. So if we're talking about straight line motion, then we can look at a speedometer, just basically the dial there, or I guess in the newer ones, just the digital display. We know there's acceleration if there's a change in speed, and therefore if the number changes, if the needle moves, or if the number that being displayed moves, then we have change in speed, therefore we have acceleration. Problem 82. Correct your friend who says the dragster rounded this curve at a constant velocity of 100 kilometers per hour. Now, remember, velocity is speed and direction. And if the acceleration is constant, if the velocity is constant, that means the speed doesn't change and the direction doesn't change. So if he's going 100 kilometers per hour, but he is curving, the direction is not changing. If you go around a curve, think about the finger as the direction of the velocity at any particular moment, then as he goes around the curve, the direction is constantly changing. If the direction were not changing, he would be going in a straight line, which he is not here. So your friend, once again, is wrong. 83. Cite an example of something with constant speed that also has varying velocity. Now, constant speed with varying velocity, since velocity is speed and direction, if the speed is constant and the velocity is not, that means the direction is not constant. So that would be an example of something traveling in a curve at a constant speed. So very similar to 82, at least the explanation for 82. Cite an example of something with a constant velocity and a varying speed. Well, velocity is constant. That means the speed and direction are both constant. And, well, if the velocity is constant, the speed has to be constant by definition. 86. A, can an object be moving when its acceleration is 0? If so, give an example. Remember, acceleration, again, deals with a change in velocity. So can it be moving with an acceleration of 0? Absolutely, just so long as the velocity stays constant. And remember, are you moving right now as you look at the computer? And you could be sitting as still as possible from your point of view, but you're on the Earth and the Earth is spinning and so forth. How fast an object goes, whether an object's moving or not, depends upon the reference frame. Relative to what? And so, yes, of course, you can have acceleration 0 and still be moving. That's called dynamic equilibrium, which we dealt with in the previous chapter. B, can an object be accelerating when its speed is 0? Yeah, there too. If I throw a ball in the air and it goes from going up to down, there's a brief moment, throwing it straight up in the air, there's a brief moment when it stops. The acceleration is still not 0. It still has an acceleration. And remember, if the acceleration is 0 and the speed is 0, well, if acceleration is 0, that means the velocity doesn't change, and if the speed is 0, that means that object's just going to sit there. So if you have speed 0 and acceleration 0, then object's not moving. Now, I do want to throw in one bit of the language. He says, can an object be accelerating when its speed is 0? We do assume that in this language here that acceleration of 0 is not what he's talking about. Properly, he should say, can an object have non-zero acceleration when its speed is 0? That, in essence, is the question that I just answered. Problem 88. On which of these hills does the ball roll down with increasing speed and decreasing acceleration? Well, in all of them, the speed is going to increase. As it falls, again, using language from Chapter 7, which I really don't want you doing at this point, but I'm doing it anyway, the gravitational potential energy is decreasing, so the kinetic energy is increasing. However, if we think about it in terms of force, there's a force downwards acting on it, and so we have a force in part A. We're concerned about how much of that weight is actually down the ramp, actually in all three cases. And so they're looking for increasing speed. That's going to be all of them, because they're all going to a lower level and picking up speed. And then decreasing acceleration. Well, in the first one, where you just have the straight ramp, the acceleration is going to be constant all the way down, because the acceleration is dependent upon the angle at which it's falling. In B, it starts out steep and then it smooths out, so it's going from a very high acceleration to a much lower acceleration. At an extreme, if it started out in free fall and then went to horizontal, when it's in free fall, the acceleration is the acceleration due to gravity, and then at the end, the acceleration is zero when it levels off. So that would be decreasing acceleration. And then the last one, it starts out flatter like this and then drops off. And so the acceleration starts out low and then increases. So increasing speed and decreasing acceleration, that would be the middle one. Number 91, if you drop a coin, its acceleration towards the ground is 10 meters per second squared. If you throw it down instead, would its acceleration after throwing be greater than 10 meters per second squared? Why or why not? Again, we're assuming no air resistance like we've done for a lot of these problems. But once it leaves the hand, the only force acting on it is the force due to gravity, and I guess until it hits the ground. If the only force acting on it is the force due to gravity, the acceleration is the acceleration due to gravity, excuse me, which is a constant. And so, So whether I drop it, throw it up in the air, or throw it down, once it leaves the hand, the only force acting on it is its weight, force due to gravity, and therefore the acceleration is going to be the same no matter which way, if I just drop it or throw it. Now, the velocities will be different, the speeds will be different, but the acceleration is still the same. The velocity will still change once it leaves the hand at the same rate. Problem 93, a friend says that if a car is traveling towards the east, it cannot at the same time accelerate towards the west. What is your response? I would say your friend is wrong, or that friend is wrong again. If it's traveling east, so let's just say that's east, and then it is accelerating west, that just means the acceleration's in the opposite direction. The car is slowing down. If you're driving east and slowing down, your acceleration is to the west. It's as simple as that. Number 94, Madison tosses a ball straight upwards. Anthony drops a ball. Your discussion partner says both balls undergo the same acceleration. What is your response? Again, as we talked about many times before, once it leaves the hand and the only force acting on it is the force due to gravity, then you can easily make the claim that the acceleration is the same. If you want to get into the nuances that, one is higher than the other one, and therefore the accelerations are different by 1/1,000,000th of a meter per second squared, sure, you could make that argument that the one closer to the ground would have the higher acceleration due to gravity, but again, you need the multi-million-dollar equipment to measure that difference in the accelerations. So especially for 110, but even into the physics that I dealt with in graduate school, we would consider that acceleration to be the same.